Hey everybody, it's Brian again, back for some more Java. So this is the second time I've done this video. I deleted the first one because I thought it was a little too long. So let's just do this again, shorten it up a little bit. This is a classic interview question I've heard used before in the actual real world. So let's take a look at it and see if we can solve it. So our challenge is going to be to write a method that takes two rectangles as parameters. So let's just stop there and just take a look at what a rectangle is. The rectangle has x, y, width, and height as its accessible property. So I just went ahead and made something like that. I called it my rectangle. So we can actually make some of these and print the results of them. So if you want to do that real quick, this isn't really part of the interview question, but the rectangle is as such with the constructor and these four fields and everything like that. Okay. So if you want to kind of pause it and look at this so you can program it in, that's fine. So what we're going to do is our method should return a rectangle representing the overlap between the two rectangular regions. So let's take a look at what they mean here. So let's take a look at, here are some rectangles. Kind of just drew these out real quick. So here's one rectangle and here's the other. So sometimes these rectangles might not overlap. They might overlap a little bit, or one of them might fully engulf the other. They might overlap in a lot of different ways. They could be out of reach in many different ways. So this is pretty challenging. So if you want to pause the video here and kind of try to visualize how you do this, considering that the upper left corners are the x, y coordinates of the rectangle, then go ahead and do that and come back and see my solution and see if you agree with it, see if you find any holes in it, or whatever. Maybe you like it altogether how it is. So let's go ahead and try, okay? So if you want to try to consider all these cases, all the ways that these rectangles can overlap, it's a bit much to consider, right? But if I could only reduce this problem to a one-dimensional problem first, then we might see like how we might want to do this. So let's take a look at just the widths of these rectangles. Okay, I'm having some like formatting issues here. So this purple one represents the width of this, of one rectangle, and this red one represents the width of the other. So ignore these rectangles just for a second and take a look at the way that two lines can overlap. Right? So I guess one of them could be completely off to the left and not overlap at all. They could overlap a little bit. This could be fully inside this one. This other one could be fully inside of this one. This one could stick out a little bit further. This one could stick out of this side a little bit further, right? So this, even if you reduce it to just the single dimension, there are too many cases to really feel good about an algorithm. But if we decide that we want to say that one rectangle is the left rectangle and one rectangle is the right rectangle, then it reduces greatly, right? So which way? So assuming that this purple line must start to the left, how many ways could these two lines overlap or exist with each other? So I guess this one could be fully inside of this one. This one could extend past a little ways, or this one could be entirely out of reach, right? So only three cases. If we know which line is on the left, we only have three cases to consider. Okay, so that's going to be what we're going to do first. We're going to determine which rectangle is the left rectangle, which one's the right rectangle. Then we can calculate the overlap width and height pretty easily from there, right? With only three cases, right? Then what we're going to do is we're going to turn it vertically. We're going to turn the problem vertical and do the same thing, right? If we determine which rectangle is the up rectangle and which one's the down, then we're going to be able to get the overlap height pretty easily as well. All right, so let's get started. I'm going to flip these on their side so we can look at these when we need to. All right, so let's write the method header first and we'll get going, and let's see if this is a satisfactory solution. Let's see. So let's call it, let's say it needs to return a rectangle, so here it is. Let's call it find overlap. And it's going to take my rectangle R1, and let's make the other one R2. All right, so let's keep track of all the things. So our answer is going to be a rectangle that has, I'm going to call this the overlap X. I need an int, I'm sorry. I'm going to call this an int. Let's consider these are all ints. Okay, overlap X, I'm going to need an overlap Y. So eventually I'm going to construct a rectangle with all of these. Overlap width and the overlap height. Okay. So once I know these numbers, then I can just return a new rectangle with those. So I suppose at the end of the function, it's just going to be, I'm going to return a new myRectangle object that has these properties, right? Overlap x, overlap y with the overlap width and the overlap height. All right. So I suppose that's it for the 4 features of that rectangle. Now it's going to calculate them. That's the challenge, right? So let's figure this out. So I think we're going to need to determine, remember what we said, we're going to determine which rectangle is the left rectangle. And we're going to need a right rectangle, right? Similarly, we're going to need, when we flip this problem on its side and do the vertical stuff, we're going to need an upper rect, and we're going to need the lower rect, right? So there's no guarantee, by the way, right? There's not 4 rectangles, right? There's only 2 coming in. One of them will be the left, one will be the right. One of them will also be the upper, and one of them will be the lower. But you know, I don't really know if the right one is going to be the upper one or if the left one is going to be the upper one. And in fact, it doesn't matter in the end. I think all we need to do, we're going to use these just to calculate the width and the height of the region, the overlapping region, and then determining the beginning of the overlapping region or the coordinates of the rectangle is actually probably the easiest part. So let's go ahead and parse this out. We got to determine the left rect. Okay, determine the left and right rectangles, and it's going to be pretty easy, right? So if rectangle 1's x component is less than or equal to rectangle 2's x component, then we have the left rect is going to be R1 and the right rect will be R2. I don't think that's too taxing mentally, right? Less than or equal to meaning, I guess if there's a tie, then one of them has to win. I guess if they're tied, then let's let the rectangle be R1, which is kind of inconsequential which one you choose. But if that's not the case, then it must be that the left rect is R2 and the right rect is R1. And while we're at it, let's just use this same kind of structure. And we're going to determine the upper and lower, right? So I want to determine upper and lower. So that when we want to use them to calculate, it'll be easy. And we won't have to do this check again. So it's going to be the y components, right? All of these y components, and instead of being left and right, it'll be upper and lower. Now it's kind of weird to look at this like, the way I'm visualizing upper is, you know, if you're, let's say this is my screen here. Let's follow my mouse if you could. Y is actually 0 up here in the corner, and then it extends in the positive direction this way. So if a y is actually lesser, that means it's higher up. So if the rectangle 1's y component is actually less than or equal to R2, that means the upper rectangle is R1. That makes sense? So it's kind of like upside down y-axis, like most graphics objects and things like that view it that way as well. So we have, so just to kind of, if I haven't clarified this yet, the coordinates of the rectangle, the xy coordinate, is not actually the center of the rectangle, it's the upper left corner. So you can see here that the blue one is the upper rect, its y component is smaller than this one, right? So I guess this y component could be like, I don't know, 5, and this one might be like 10, okay? Maybe a little bit of over-explaining happening there, but let's get back to the eclipse if it'll let me. I suppose I have to escape here. Okay, so we have the upper, lower, we have the left and right. So let's go back to the visual aid quickly, and we will calculate the overlap. So our goal here is going to be to calculate the overlap width. All right, so there are only 3 possibilities we really need to think about, right? So if this purple one is guaranteed the left rectangle, we have this case here where it's like totally out of bounds. Let's program that in. So if there is no overlap x, then we know that we can return null. There is no overlapping rectangle at all. It's just out, they don't overlap. So what does that look like? I guess if it's the left rectangle's x component plus its width doesn't even get to the right rectangle's x component, then we have no overlap. So I guess that would mean if the left rect x plus its width, not equals, come on man, plus the left rect width doesn't even reach or is less than, how about less than or equal to the right rect's x, then we have no overlap. Okay, so this is a no overlap scenario, and we can just return here with no rectangle at all. Now I guess I said less than or equal to because if I have this one kind of just getting to this one, right, then they're really just like there is no rectangle there. It's like a line, right? So less than or equal to would be what I would say. What about another scenario? How about this? It's fully inside of this one. So I guess that means if the left rectangle's x plus its width extends past the right rectangle's x plus its width, then we have a fully overlapped. Okay, so I guess if the left rect, it's going to be like this. It's going to be this. If the left rect x plus its width is greater than or equal to the right rect x plus its width, then we have a full overlap. Okay, so this is fully overlapped. So let's just comment that. Fully overlap. So I guess then it's pretty easy to see what the overlap width is then in that case. You can kind of see that the overlapping region's width is just the width of the rectangle on the right. So let's just say that. We're going to say that overlap width is actually equal to the right rect's width. So that's going to be pretty easy. So I guess the last part, the only one else to consider is that if it kind of is like partially overlapping, right? So that means that if that's the only other case, so I can just say else. But so let's just say else, so we don't have to program that another else if. So we're just going to say else, and then we're going to call it a partial overlap, just to be clear about what we mean. It's partially overlapping. I can't think of any other scenarios with those lines. So the overlap width is right here, which is I guess the right edge of this pink or purple rectangle to the beginning of the red one. So that's the left rect's width plus its x minus the right rect's x. Does that make sense? So the left rectangle is x plus its width minus the right rectangle's x. That's the overlap width. So I guess I can just go ahead and say that right rect. Oh, sorry. It's going to be the overlap width is going to be the left. I'm just going to borrow this because I'm lazy. This one. It's taking longer for me to copy it than it is for. I should have just written it. Minus the right rect x. All right, that feels good to me. So I've finished the calculating the overlap width. Now calculating the overlap height is exactly the same scenario. Calculate the overlap height. It's going to be so similar that it's ridiculous, right? So we're going to have the same deal, right? So let's say that it's out of bounds, right? So let's look at the visual again. Let's say the purple one is upper and the red one is lower. It really doesn't matter. I don't want you to think that it matters that the red one was once the right. I understand that. So it could be that, that the red one is the upper, but we will have an upper and a lower. Does that make sense? So what does it mean to be out of reach? It means that the upper rectangle's y plus its height doesn't even reach the y component of the lower rectangle. So we have no overlap. So if the upper rect y plus the upper rect's height doesn't even reach or is equal to, I suppose, the lower rect's y, then we're going to have no overlap. No overlap it is. And then we can just return null here. A little sound going on there. I don't know what that is. Else if. So I guess we're going to have this other one would be a full overlap, right? This is what we did last time. So I don't think we really need the visual anymore. I would welcome you to, if you need the visual, is to kind of maybe do it yourself. But I think you guys get it. If the upper rectangle's y plus its height is even higher than or extends past or is equal to the lower rect's y plus its height, then we have that full overlap. Right, so that's the full overlap, and then I guess that means that we're going to say that the overlap height is the height of the lower rectangle, right? Let's just look at it one last time, right? So if it's fully engulfed here, then the overlap height is just the height of the lower rectangle. Does that make sense? That looks like this. It's going to be the lower rect's height, right? And that's it. And then I guess we have the partial overlap, right? This is the partial. And let's just look at it just for visual sake. It's going to, if we have a partial overlap, it's going to be the bottom edge of this purple one to the top of the red one. So it's the upper rect's y plus its height minus the lower rect's y, right? So that's that area right there. Upper rect's y plus its height minus the lower rect's y. So it's going to be overlap height is equal to the upper rect y. Let's see if I can do any better here. Upper rect y plus its height minus the lower rect's y. Feel good about that. Then we are done, right? We have now. Oh, actually, no. We need to determine where the beginning is, right? We've calculated the width and the height, and now we just need where the rectangle begins. Okay, so this one's actually not that hard. So let's take a look. Now, assuming, what we don't have to consider now is where there's no overlap. So at this point in the function, we already know that there will be an overlap, right? Because if there wasn't, we would have exited the function right here through these null checks, right? So assuming that we do have an overlap, the x component of the overlapping region is always the x component of the rectangle on the right. You see what I mean? Even if this one's on the right. If I could bring it to the front, right? So even if this blue one's on the right, the rectangular region always begins at the x coordinate of the rectangle on the right. Does that make sense? No matter how I organize these things, it's the x component of the right rectangle where the overlapping region begins, right? No matter what. So let's go ahead and say that. We're going to say that the overlap x is just going to be the right rectangle's x component, right? Not bad. And then very similar for the y component, right? The y component of the overlap region is always the one that's lower, right? So even if I bring this one, this blue one lower, it doesn't really matter, right? The y component of the overlap is that of the lower rectangle, right? So I guess it's just going to be the overlap y is just going to be the lower rect's y component. And then we have a full solution here. So I feel pretty good about that. So if we could, let's actually create a few rectangles. Let's say my rectangle, let's just test one. R is going to be R1, new my rectangle. Let's just do a few test cases. Let's start it at the origin. So it's going to be 0, 0 with a width and height of 10. And then we'll make another one. So where should I put this one? Kind of like, should I put it inside? Let's make it at like 7, 7. And then, I don't know, it also can have a width and height of 10. So what does that look like? So if the origin is like up here, right? Let's say that's the origin right there. That's 0, 0. And this is 10 by 10. And then if this one is also a 10 by 10, but it begins at 7, 7, we can see that this rectangular region where they overlap should also begin at 7, 7 with only a width and height of 3, right? Because we need to get to 10 in each direction. So it should say 7, 7, 3, 3, I suppose, right? So let's just let's find the overlap between these two rectangles. Let's print out sysout and find overlap between R1 and R2. So it'll print the little toString thing that I made here for the myRectangle class. So what should we get? We should get 7, 7 and a 3, 3. Do we? We do. Okay, let's make sure this works. Let's put one of them out of bounds. Let's just check a couple more. Let's put this one way out at like, I don't know, 27, right? Then we should get no overlap. And it should return null for us. It does. How about one? Let's just reverse these. Let's make sure order doesn't matter. I'm gonna make this one 0, 0, 10, 10, and this one 20, 0, 10, 10. Let's make sure that order doesn't matter. That should also be null. It is. How about one where one's fully inside? A couple more test cases. Can we put that one at 0, 0 with 10, 10? And then let's make this one like a 1 by 1 and place it at like 6, 6. Right? So if it's like at 6, 6 and 1 by 1, then I guess we should get back a rectangle that's at 6, 6 and is a 1 by 1. Right? So let's let's say that. So if this is 0, 0, let's make this a 6, 6, and a 1 by 1. So that rectangle should come back to us. Okay, that looks good to me. So let's just check a couple other cases. What if it's like right there, snuggling on the edge? Like if we have a rectangle that's like right on the edge, right? So this is 0, 0, 10, 10. So this will be 10, 3, and then whatever, right? So let's make sure that we don't get 0, 0, 10, 10. Let's put this one at like 10, 3, and I don't know, 10, 10. So the edge should be like snuggling up there against, but there is no rectangular overlapping region. Let's make sure that it tells us null. I'm trying to get all the cases here. Good. But if I scoot this in just a little bit, like 9, 3, can I scoot this in a little bit? Then I should get a width of 1 and a height of 7, right? Because remember, this is down at 3. So 1 and 7 beginning at 9, 3. Let's see if that works. 9, 3 with a 1 and 7. This feels pretty good to me. I think this is a clean algorithm, and I like the solution. I think this is one that I've heard some big tech companies in the area use on some of my friends, and it could be challenging if you don't determine which is the left and right rectangle. And I'm not sure if this is the most optimized solution. There maybe is some redundancy or whatever, but this worked for me, and I understand it really well. So if you have a better way, I'd love to hear it, just for my own interest. So go ahead and leave me a comment, leave me a message, whatever. And I hope this helped you in your interview prep or whatever you guys are doing out there. Leave me a message if you have any questions, and I'll follow up. All right, you guys, I'll talk to you later. Happy coding.